Hello everyone and welcome to this tutorial. Today I am going to walk you through the process of creating an employee management REST API using Spring Boot 3.0, Spring Data JPA and integrating it seamlessly with the MySQL database. Whether you are here to gain a wealth of knowledge, this tutorial is perfect for you. But before we start, let's make sure you are all set up. Ensure that you have MySQL installed on your machine. If you haven't installed it yet, don't worry. I have created a video on how to install MySQL Server on Windows 10 and you can find the link to that video in the description box below. Be sure to check it out and follow along. Now, let's talk about what we will accomplish in this tutorial. With this API, we will be able to perform the basic CRUD operations on employee data. Means we can create, retrieve, update and delete operations. Once we have built this API, I will also demonstrate how to test it using Postman. So, without further ado, let's get started by creating a Spring Boot application and importing it into IntelliJ IDEA. To do that, we will head over to the Spring Initializer website at store.spring.io. I have included the link in the description box for your convenience. Here, you will see various build tools available. You can choose between Maven or Gradle project. For this tutorial, I will select Maven. Next, you can choose your preferred programming language. We will be using Java. Now let's choose the Spring Boot version. You will see several versions available, but for this tutorial, we will use 3.0.11. In the group field, enter com.ts.inc. For artifact, type employee-management-API. Brief description. Enter employee management application. To organize our project efficiently, we will set the package to com.ts.inc.employee-management.api. For packaging, we will stick with the default jar. Moving on, you can select your Java version. I will be using Java 17 for this tutorial. Make sure Java is installed on your machine before proceeding. Okay, now let's add the dependencies we need for our project. We will require Spring Web. Then we will add Spring Data JPA. Next we will add MySQL. Then we will add Lombok dev tool as well. Okay, great. With our project configured, it's time to download it. Simply click the generate button and now you are all set. But that's not all. We are just getting started. Now let's import our project in IntelliJ IDEA. As you can see, the project is right here. Next, navigate to the form.xml file where you will find the dependencies we added when setting up our project. These dependencies are backbone of our project and they include Spring Boot Starter JPA, Spring Boot Starter Web, MySQL connector and Lombok. They are essential for the smooth operation for our employee management API. Now our application is set to connect to a MySQL database. To configure this, open your MySQL workbench. I already have it open here. Let's create a new schema, connect to it and create a table to store our data. Click on new schema and give it a name, perhaps employee repo. After that, hit apply button and you will see that the employee repo schema is created. We will be using the schema while employing Hibernate to create a table and store the data using JPA. Now let's dive into our code. First, let's add the MySQL configuration in the application.properties file to establish a connection with MySQL. I will add server.port equal to 8081. Since my application runs on that port, here is the configuration for MySQL. I am copying and paste it from here from my local. Let me give you a brief overview of this configuration. Server.port equal to 8081. This sets the port on which your Spring Boot application will run. In our case, it will be accessible at http://localhost 8081. This is especially useful when running multiple applications on the same machine without port conflicts. Next one is spring.datasource.url equal to jdbc:/mysql:/. /localhost:3306 employee repo use SSL equal to false. This configures the URL for your MySQL database including connection detail. We are connecting to MySQL database on the local machine localhost using the port number 3306 with the database name set as employee repo. The use SSL equal to false disable the SSL encryption for simplicity during the development and testing. Next one is spring.datasource.username equal to root. This specifies the username used for authenticating with the MySQL database. In this example, it's set to root, a user with the administrative privileges. Next one is spring.datasource.password equal to password. Here we set the password for MySQL user specified in spring.datasource.username. Remember, in production, it's crucial to use a strong and secure password. For demo purpose, I am using simple password. Next one is spring.jpa.hibernate.ddl-auto equal to update. This property configures how Hibernate, the JPA implementation used by Spring Boot, handles database schema changes. When set to update, Hibernate will automatically update the database schema to match your entity classes whenever changes are detected. This is incredibly convenient during development but should be used carefully in production environment. Finally, we have spring.jpa.sourceSQL equal to true, which instructs Spring Boot to log the SQL statements executed. When set to true, you will see the SQL queries generated by the Hibernate in your application's logs. This is invaluable for debugging and understanding how Hibernate interacts with the database, especially when troubleshooting is used or optimizing performance. Now let's move on to set up the project structure for our employee management system. We need several packages to keep our code organized effectively. I will walk you through creating these packages step by step. Now right click on your project, then choose new and create controller package. Then similarly create model, repository, similarly and service package. Now that we have our packages ready, let's create our core classes that form the backbone of our employee management API. We will start by creating the employee controller class, which handles HTTP request and manages our RESTful endpoints. Similarly, we will create employee model class, which acts as blueprint for our employee entities. Similarly, we will create employee repository interface. Now we will create employee service class. Finally, employee not found exception class. Okay, now we are all set. Now let's go to our employee model class. We will mark it as an entity using the @entity annotation. This annotation signifies that instances of this class will be stored as rows in a database table. We also use the table annotation to specify the table name, which in our case employee_tbl. Now that we have our employee model class set up, let's define the attributes that an employee should have. We include attributes such as private, long ID, private, string, first name, similarly last name, email ID, job title, department name, phone. These attributes represent the essential information we want to store for each employee. To define the primary key, we use the @id annotation. We also use @generated value to specify that the id value should be automatically generated using generation type .identity. Let's start to annotate @column annotation to define our column name. @column of name id. For first name, first_name, last name, last_name. Similarly for other attribute as well. Okay, now let's dive into the detail of the @column in JPA. The @column annotation is a JPA, a Java persistence annotations that is used to specify the mapping between an entity class's attribute, a field in the Java class, and the database column. It provides detailed control over how the attribute is stored in the database, including the column name, type, length, and various constraints. Here is a breakdown of the key attributes and uses of the column annotation. First one is name of string. This attribute specifies the name of the database column to which the entity attribute should be mapped. It's particularly useful when the column name in the database differs from the attribute name in the Java class. In our example, the first name attribute in the Java class is mapped to the first underscore name column in the database. Next one is Boolean unique. The unique attribute specifies whether the values in the column must be unique across all rows in the table. When set to true, it enforces a uniqueness constraint on the column. In our example, the employee underscore code column is marked as unique. This means that each employee must have a unique employee code in the database. Next one is Boolean nullable. The nullable attribute specifies whether the column allows null values or not. Setting it to false means the column cannot have null values. In our example, product underscore name column is marked as nullable equal to false. It's indicating that it cannot store null values. Every product must have a name. Next one is length of int. This attribute specifies the maximum length of a string attribute. Example, varchar in the database. It's typically used for attributes of type string. In our example, it's expected to hold strings of up to 100 characters. Next one is precision of int and scale of int. These attributes are used for specifying the precision, the total number of digits, and the scale, the number of decimal places for numeric attributes. They are typically used with the attributes of types like big decimal. In our example, the salary column can store a numeric value with a total of 10 digits including 2 decimal places. Boolean updatable. The updatable attributes control whether the column can be updated when performing database updates. Setting it to false means the column is read-only and cannot be modified. In our example, name equal to order underscore status column is marked as updatable equal to false, making it read-only. So once an order status is set, it cannot be changed in the database. And insertable of Boolean. Next one is the insertable attribute controls whether the column can be inserted when adding new records to the database. Setting it to false means the column cannot be included in insert operations. In our example, the creation underscore date column is marked as insertable equal to false, which means that it won't be specified during insert operations. The database will handle its insertion automatically, such as with a timestamp. @column annotation is a powerful tool for customizing how your entity attributes are mapped to a database columns. It allows you to define column-specific properties, constraints, and behaviors to suit the needs of your application and database schema. To keep our code clean and concise, we will make use of Lombok, a fantastic library that helps reduce boilerplate code. We will annotate our employee model class with the @data annotation. This annotation generates common method like getters, setters, equals, and hash code method, making our code more readable and maintainable. Next, we will add allR constructor. It generates a constructor that includes all the fields, making it easier to create an instance of employee with all the field values. Next, we will add nor constructor. It generates a parameterless constructor which can be useful in certain situations. And then we will add a toString. It generates a toString method for a human readable representations of the object, which can be handy for debugging and logging. Finally, in addition to Lombok, we also implement the serializable interface for our employee model class. This step is essential because instances of this class will be stored in a database and object serialization is necessary for smooth data storage and retrieval. Let's add serial version ID. Now let's create our employee repository. This interface plays a significant role in our Spring Boot application. Here is how it's work. We annotate it with @repository. indicating that it's a Spring Data repository. This annotation tells Spring to manage this interface as a Spring Bean, making it injectable into other parts of our application. But the real magic happens when we extend JPA repository. JPA repository is part of the Spring Data JPA framework, and it brings a treasure trove of CRUD, create, read, update, delete operations to our fingertips. It simplifies database interactions significantly. That first type parameter employee specifies the entity type that this repository is managing, which in our case is the employee. This alignment ensures that the repository operates on employee entities. The second type of the parameter long specify the type of the primary key of our entity. In our employee entity, ID is of type long, and this parameter aligns perfectly with it. Now let's start to create employee service class. This class acts as a bridge between our controller and repository, encapsulating the business logic and managing employees. Here is how it's set up. We annotate the employee service class with @service annotation, marking it as a Spring Service component. This annotation tells Spring to manage this class as a bean, making it accessible for injection into other parts of our application, like controllers. For the magic to happen, we use @auto-void annotation to inject an instance of the employee repository into the employee service. This enables our service to interact seamlessly with the database through the repository, allowing us to perform CRUD operations with ease. Now let's create our REST endpoint. To create our REST endpoint, we will be working within the employee controller. This class is the heart of our application and plays a pivotal role. Here is how it's set up. Employee controller is annotated with @REST controller, which signifies that it's a Spring MVC controller responsible for handling incoming HTTP request. We have also added the @request mapping annotation. Within that one, we are passing as a parameter /API at the class level. This annotation sets the base URL path for all the request mapping defined within this controller. In simpler terms, all the endpoints we define here will be relative to /API. Now let's talk about the employee service class. It's a crucial piece of our application responsible for managing employee data. But what makes it even more interesting is how it's utilized in the employee controller class. @auto-void annotation ensures it can communicate with the employee repository and handle the underlying database operations seamlessly. This brings us to constructor injection. The employee controller class features a constructor that takes an employee service parameter. This is a form of dependency injection, a fundamental concept in Spring Boot. Why constructor injection matters? Dependency injection is the secret sauce that makes Spring Boot so powerful. It allows us to inject dependencies into our classes rather than having to create them ourselves. In this case, we are injecting the employee service into our employee controller right at the moment it's created. Now let's create the add employee method. This method is pivotal in our application, allowing us to add new employees to the system. This method will return an HTTP response, and we will use a handy class provided by Spring called a response entity to accomplish this task. Let's break it down step by step. We will use the response entity, which is a generic class, and we will specify that it will handle employee entities. This is because we want to return an employee entity in our HTTP response. The add employee method takes a request body of type employee and is annotated with @post mapping. We map this method to the URL /employee, indicating that this endpoint will handle post request for adding employees. Inside the add employee method, we create an employee object by calling employee service that add employee. We pass the employee object received from the request to this method. Next, we return a new response entity instance. Within this response entity, we include the newly created employee and specify the HTTP status code as created HTTP 201. This indicates that the employee has been successfully added. Now moving to the employee service class. In the employee service class, we define the add employee method. This method takes an employee object as a parameter and plays a crucial role in adding a new employee to the database. To achieve this, we utilize the employee repository.save method. This method is provided by Spring Data JPA and handles all aspects of database interactions, including generating a unique ID for the new employee. After saving, the method returns a saved employee object, which now includes the unique ID assigned by the database. Now we are going to create a method to get all employees. This method will be a crucial part of our application, enabling us to fetch a complete list of employees. To create the getEmployees method, we will annotate it with @getMapping. This annotation tells Spring that this method will handle HTTP GET request. We will map this method to the URL/employees. The purpose of this method is simple but vital. It handles HTTP GET request, and when triggered, it invokes the findAllEmployees method of our employee service. Upon successful retrieval, this method returns a response entity containing a list of employees with the status code 200, that is HTTP status.ok. This HTTP status indicates that the request has been successfully fulfilled. Now let's head over to the employee service class and add the findAllEmployees method there. Here is how it's done. The findAllEmployees method's responsibility is very clear. It retrieves all the employees from the database. We achieve this by calling the employee repository.findAll method, a handy feature provided by the Spring Data JPA. This method returns a list of all employees available in our system. Now we will be creating the findEmployeeById method. This method is essential for fetching employee details by their unique ID. To create the findEmployeeById method, we will map it to the getHTTP request at the path /employees/ID. Here ID is the path variable representing the ID of the employee we want to retrieve. To extract this ID from the URL, we will use @path variable annotation. This allows us to seamlessly work with path variables in our Spring Boot application. Within this method, we will call employee service.findEmployeeById of ID. We are passing ID to retrieve the employee by their ID. This method returns a response entity that contains the retrieved employee in the response body along with an HTTP status 200, HTTP status.ok. This indicates that the request has been successfully fulfilled. Okay, now let's head over to the employee service class and create the findEmployeeById method. Here is how it's done. findEmployeeById, we are passing the parameter longId, is a method responsible for retrieving an employee by their ID from the database. We achieve this by using employee repository.findEmployeeById and the parameter we are passing ID. In case the employee with the provided ID is not found, our application throws a employee not found exception. This is a custom exception that we have defined to ensure that when an employee with the given ID does not exist, the application responds with an appropriate error. Next, let's create the findEmployeeById method in the repository. This method allows us to retrieve an employee by their ID. Optional employee findEmployeeById of long ID is the method signature. It returns an optional employee to handle cases where an employee may not exist with the provided ID. Spring Data JPA works its magic here. It generates the SQL query for us based on this method name. So we don't need to write explicit SQL queries for common operations like finding or deleting entities by their ID. Now lastly, let's go to the employee not found exception custom exception class. This class ensures we handle situations where an employee is not found gracefully. Let's define @response status of value equal to HTTP status dot not found on the class level. This annotation specifies that when this exception is thrown, the response to the client will have a 404 not found status code. This exception class extends runtime exception, making it an unchecked exception. Unchecked exceptions don't need to be caught or declared in the method signatures, making them suitable for indicating runtime errors. We also have a serial version UID to ensure proper deserialization, and a constructor that takes a string message to provide additional information about the exception. We are taking the next step and creating the update employee method. This method allows us to update an existing employee's information in our database. So let's get started. To create the update employee method, we will focus on handling put request made to /employee/id, where id represents the id of the employee we want to update. When a put request is made to this endpoint, it triggers the update employee method within the employee controller. Within this method, we use @path variable of id, long id, to extract the id value from the URL's path, and we use @request body employee to bind the JSON data provided in the request body to an employee object. Additionally, we set the employee's ID using employee.setId of ID to ensure we preserve the employee's unique ID. Now, with our updated employee object, we call the update employee method in our employee service to initiate the update process. The method returns a response entity that contains the updated employee in the response body along with an HTTP status of 200 OK. This indicates that the request has been successfully fulfilled. Now go to our employee service class. Within the employee service, the update employee method interacts with our employee repository, which in turn updates the employee's information in the database. The updated employee is then returned to the employee service, which subsequently sends it back to the employee controller. Finally, the employee controller responds with a JSON representation of the updated employee accompanied by an HTTP status code 200. This indicates a successful update. Now we are going to create delete employee method. This method allows us to remove an existing employee from our database. So let's get started. In our employee controller class, we have defined the delete employee method to handle delete request sent to the endpoint /employees/id, where id represents the unique id of the employee we want to delete. When a delete request is received, the delete employee method in the employee controller takes charge. It all starts with a call to employee service.delete employee of id. This line of code forwards the responsibility of deleting the employee to our service. The method returns a response entity with an HTTP status of 200 to indicate that the request has been successfully fulfilled. Now let's delve into the delete employee method within our employee service class. Here we ensure that the deletion process is carried out effectively. Within our employee service, this delete employee method is responsible for coordinating the deletion operation. It commences by checking if the employee exists using employee repository.findById of ID. If the employee is found, we proceed with the deletion. Using employee repository.delete.existing employee, we carefully erase the employee's records from our database. Here is an important point to note. The delete employee method within the employee service is void, meaning it doesn't return any specific data. Instead, it focuses on efficiently managing the deletion process. While the delete employee method in the employee service does not explicitly return the HTTP response, the delete employee method in the employee controller ensures that the HTTP status is returned to the client. When the deletion process successfully completes without any exceptions or any errors, Spring Boot automatically interprets this as a successful operation and responds with an HTTP status code 200 status.OK. This is done by returning new response entity of HTTP status.OK in the employee controller. In essence, The delete employee method in the employee controller returns the HTTP status code, while the delete employee method in the employee service focuses on the core logic of the deletion process. With the delete employee method now well understood, we can efficiently remove employee records from our Spring Boot application. This process is fundamental for maintaining data accuracy and integrity in our employee management system. In summary, a request comes in through the API. It could be asking to add, get, update or delete an employee. The request is called by the employee controller. It figures out what the request wants, add, get, update or delete. The controller talks to the employee service saying, hey, someone wants to do this with an employee. Can you handle it? The employee service does the work. It might ask the employee repository to find or change the employee information in the database. The employee repository communicates with the database using JPA magic, finding, adding, updating or deleting employee data. If everything goes well, the data flows back up through the layers and the response goes out through the API as a nice JSON package. If something goes wrong, like asking for an employee that does not exist, the employee not found exception steps in and says, oops, that's not here. The whole thing is ignited by the employee management API application and your application is up and running, ready to manage employees. Great! We have successfully implemented all our methods and now it's time to build our Spring Boot application and test it using Postman. To run your application, open Employee Management API application class in your project. You can do this by locating the class file in your Project Explorer and double click it. Once you have the Employee Management API application class open, you will notice a green button at the top. Click this button to start your application. Alternatively, you can also click Run here in the application Employee Management API application class itself. Now your application will start now. With your application started, you will notice in the console log that Hibernate has created the employee_TBL table as we specified in our employee model. The table includes all the attributes we added as columns with ID as the primary key. However, you may observe that the column names in your database are in lowercase and don't match with the column names defined in your entity class. If you encounter this issue, you can address it by adding a naming strategy for Hibernate in your application.properties file. To do this, open the application.properties file and add the following configuration. We have to add implicit strategy and physical strategy. Implicit naming strategy legacy JPA IMPL, physical naming strategy standard IMPL. Both are located in the org.hibernate.boot.model.naming. Okay, now once you have added these lines, save the file, stop the server, rebuild your application using Maven commands. You can do this by navigating the Maven panel, clicking on lifecycle and then running clean. You will see build a success message. Then go to lifecycle again, click install in the lifecycle again, then run. You will see build a success message. Here you will notice that Hibernate has recreated the table with the appropriate column names. These configuration properties ensure that Hibernate uses Spring's built-in naming strategy, which may help align the column names in your database with the column names defined in your entity classes. By setting these properties, you ensure that Hibernate uses the naming strategy provided by Spring, which should align with your Spring application's naming conventions. This can be useful when you want more control over how entity names and column names are mapped to the database tables and columns. If you take a look in your MySQL database under the employee repo schema, you will see the employee_tbl table created by Hibernate. You can even use the describe command to view the column names generated by Hibernate. Now, let's move to Postman. To interact with our API, remember that our port number is 8081 and the URL is http://8081/API/employees. We will use the post method to add data. In Postman, select post, method is post, choose body and then raw with the JSON selected from the drop down. You will need to pass the JSON data that matches the attributes in our employee model. When you click send button, you will see a 201 created status indicating that we have successfully saved data in our database. To verify, you can run select star from employee_table in your database to see the records. We will add 2 more records. And go to database, you can see them in the database as well. Okay, next we will retrieve all employees using get method. Go to next tab, enter the URL http://localhost:8081/API/employees. Click send button. You will get a 200 OK status with 3 records. You can also retrieve records based on their ID. For instance, you can enter http://localhost:8081/API/employees/1. Go to the next tab, enter this URL. Will give you the first record with a 200 OK status. You can do the same for the second and third records. For updating an employee is easy to go to next tab, copy the URL and use the put method here. Choose body, raw and JSON in the drop down. Now update the desired attribute. We are going to update it in second record. I'm going to change it here. Now click send button. You will get a 200 status confirming the successful update. Finally, let's delete a record. In a new tab, enter the URL and choose the delete method here. Enter the URL http://localhost:8081. We are going to delete second record. So you will see a 200 OK status. Returning the previous tab now, you can see that the second record has been deleted. Congratulations! You have just completed an in-depth journey through creating a powerful Spring Boot application and testing it with a Postman. If you found this tutorial valuable and enjoyed the learning experience, please take a moment to share your thoughts in the comment section below. And to stay updated on more insightful tutorials and exciting content, make sure to hit that subscribe button. Thank you for tuning in and happy coding.